Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning po, sir.
Morning, sir.
Good morning. No, nakalipat na ba kayo? Andito na yung iba.
Yes, sir.
So, by face-to-face natin, face-to-face natin yung sa mga sa laboratory schedule na lang natin, yung 3 hours. Though, still, ganun pa rin naman that we will not wait lang ha. For these students. So, okay. You there? We'll just continue yung ating sa convection. So, we've discussed yung convection sa mga dimensionless numbers natin. We'll discuss about yung comparison ni conduction tsaka convection, where conduction na discuss na natin and convection is the motion of fluid. So, ang convection is yung addition of conduction and advection. It's all about the fluid motion. And the two types of convection, we have yung free or natural convection at saka si force convection. So we've also compared the two categories or two types of convection, yung free at force. And then we've introduced yung mga Reynolds number, yung mga Prandtl number, Nusselt and Peclet, yung mga Grashof, yung mga ganung numbers. Now, i-introduce naman natin on how they are solved. Mabilis lang naman tayo today. Kasi by next meeting sa radiation na tayo. Kasi we will not go deeper sa convection. So this one. So we had yung free and forced convection. Mostly dito sa first three, yung Nusselt, Grashof, tsaka si Prandtl. Itong mga dimensionless number na to, mas nagagamit sa free convection, while dito sa Nusselt, Reynolds, Prandtl, Stanton numbers, nagagamit na siya sa forced convection. Mostly itong Reynolds number because andito na yung flow of water, andito yung si laminar, tsaka si turbulent flow. So, unang-una, sa pagsosolve ng ating mga force convection, ang unang kinukuha, ito si Reynolds number. And then, after Reynolds number, ayan na sina Prandtl number, Stanton number. But you can take si Prandtl number muna if there is no Reynolds number. Ganung bagay. Though madami kasing ini-introduce na it's like a rules in here in convection where, for example, in this one, pasok muna tayo kay Nusselt. Si Nusselt yung pinaka-last na dimensionless number to go through dun sa convective coefficient natin where yung convective coefficient natin na coefficient, as you can see dito sa formula ni Nusselt, ito si Nusselt is equal to convective heat coefficient times yung length over si conduction, conduction coefficient, si K. So yan, after nating nakukuha si convective coefficient, saka pumapasok na si heat transfer by convection. The same with the free convection. Ito. But this one, yun nga, dahil nga sa mga inertial forces, bago makuha si heat transfer by convective at bago makuha si heat coefficient, bago makuha si na itong mga numbers, itong mga Nusselt, Reynolds, yung mga dimensionless numbers natin, may mga inertial forces tayong kailangan. Like this one, yung mga viscosity, yung mga specific heat, of course, sina conductivity, sina mga densities natin, velocity, of course, yung mga yun. So sabi ko nga kanina, are these rules, parang equations to understand, para to categorize yung mga formula under these dimensionless numbers. Like for this example, dito sa Nusselt natin, hindi ko pa nailagay dito buo dito sa PowerPoint. I have here like a lot of equations to consider bago pupunta kay Nusselt number. If you are solving, for example, this one, if you are solving for a plate that is heated surface up or cooled surface down, we are parang computing for free convection here. If you are solving for plates, we have yung of course, we have tayong laminar tsaka turbulence flow. Ito yung formula ng equation 1, sinasalt dito is 0.54 times the quantity of Grashof Prandtl. Minsan given na si Prandtl, minsan given si Grashof. Pero yung mga Grashof tsaka Prandtl, meron kasi silang table, parang may constant sila in a specific fluid or specific gas to consider with a specific temperature. Later on, may sample problem tayo just to introduce to you kung paano siya i-compute. But we will not go deeper naman doon. So, for laminar flow, meron tayong Nusselt is equal to 0.54. This one, the equation 1. And for turbulent flow, so magkaiba sila. As I have said nga, mas mahina si laminar flow kaysa kay turbulent flow. So, 2 times 10 raised to 7 if the turbulent flow, if the flow is already computed, if Reynolds is already computed, the Reynolds number is this one, higher than 2 times 10 raised to 7, then you will go to compute for Nusselt with this equation na 0.146 times the quantity of Grashof and Prandtl numbers raised to 1/3. And if you are computing for plates heated surface down or cooled surface up, we have different equations to consider. So, yan. From 0.54, magiging 0.27. And from 0.14, magiging 0.107. Also, if you are considering long cylinder, and computing for laminar flow and turbulent flow, magkaiba na naman. Using 0.54 from plates to 0.53 na to long cylinder, the same with turbulent flow, 0.14 into 0.13. But if you are computing for cross flow over horizontal pipes, you have these equations to consider that Nusselt number is equal to 0.37 times the quantity of Grashof and Prandtl times raised to 1/4. Okay, I have a lot of equations here na kailangan i-consider bago tayo pupunta kay convective coefficient and to this convection heat transfer. Now, if you are computing for a vertical plate and a large cylinder, you have to consider this Nusselt number with 0.59 times the Grashof number of 0.25. Where turbulent flow naman, you consider this Nusselt number with 0.13 times the quantity of Grashof and Prandtl raised to 1. With inclined plates naman, you will just multiply si Grashof number by cosine theta, where yung theta natin is the angle of inclination from vertical and used vertical plate numbers. Like for example, in these vertical plates and large cylinders at letter A, idadagdag mo, multiply mo lang si Grashof number into the theta or into the inclined theta na given sa mga problem. And then if you are computing for miscellaneous solids in spheres or in short cylinders and in blocks, the following correlation has been suggested for free convection for a sphere. So for free convection, you have to use this Nusselt formula that 2 plus 0.43 times the Grashof and Prandtl number raised to 1/4. And for higher values, replace the 0.43 into 0.50 for higher values where 3 times 10 raised to 5 is less than to the Grashof and Prandtl number, which should be greater than 8 times 10 raised to 5. Cylinders, you have to consider this Nusselt number, which is 0.775 times the quantity of the Grashof and Prandtl number raised to 0.208. And for other solids naman, consider this dimensionless number in Nusselt number. We have yung 0.52 times the quantity of the Grashof and Prandtl number raised to 1/4. The same if it's inclined, you are just going to multiply doon sa Grashof number yung inclination angle natin. So equation 14. So from kwan pa lang tayo, Nusselt number, we have Prandtl's number, we have Reynolds number, yung mga numbers pa. So there are a lot to consider kasi dito sa convection. So I've decided not to go deeper and deeper na lang talaga. Kasi actually hindi naman na rin to dinadagdag sa board exam. Hindi ka naman magdadala ng table, yung mga constant table. For example, dun sa thermodynamics dati, di ba, sobrang dami ng table. You also have to understand si psychometric chart. Meron namang table na kailangan si psychometric chart. Hindi naman dinadala yun sa board exam. Especially, hindi na rin na nagagamit yun. So, yung mga basics to consider na lang sa ating heat transfer coefficient and heat transfer convection ang ating pag-aaralan for it. But I just want to introduce to you parang overlook natin kung ano yung dito, parang bibisitahin lang ba, titignan natin kung what is in here, what's to be seen. But let's just see it, let's just watch, parang ganun ba, not to internalize it anymore. So we have here equation 14 that if you are computing for plane surfaces in flow paths and flat plates and walls, that the local fin coefficient for laminar flow past a flat plate may be obtained from the correlation of this Nusselt number, where This Nusselt number is equal to 0.332 times the Reynolds number raised to 1/2 and the Prandtl number raised to 1/3. But if the following correlation has been proposed for liquid metals, if you're computing for liquid metals in plane surfaces, use this Nusselt number equation where Nusselt number is equal to 0.565 times the Reynolds number times the Prandtl number raised to 1. And then if you are computing for a plate length, average Nusselt number would be given with this one. That Nusselt number is equal to 0.036 times the Reynolds number raised to zero point 0.8 times the Prandtl number raised to 1/3. So when the flow less in the transition range, Nusselt is equal to 0.36 times the Prandtl number of 0.33 and multiplied by the equation of Reynolds number raised to 0.5 times the area.